easy. There might even be a question where it says find the derivative of x to the 6th plus x to the pi power. That should also be easy.
Yeah.
6x to the 5th power. Nobody seems to be worried about that. As long as you have x raised to a power, what does the power rule say? Pi. Pi minus 1. I don't need to know what pi minus 1 is as a number. We just bring the power down and reduce power by 1. Now here's where somebody's going to blow it. They're going to see 1 over x and be like, Daddy, I don't know what I'm supposed to do because I don't know. I only know the power rule. I'd love to get some hands on this. What would you do if the only thing you know is the power rule? 1, maybe 2, maybe 3, maybe 4. Daisy, what's your thoughts here?
I would change this to x to the power of -1.
Well, wait, is that legal? Rewriting 1 over x as x to the power of -1, is that legal?
Yes.
Indeed it is. So what's the derivative?
It's gonna be x to the power of -2. I mean -1 x to the power.
-1 x to the
-2.
-2, and if you want to clean this up, you're going to make it -1 over x squared. Nice. Another crazy one, because you know me, I'm a pusher. You might be asked to find the derivative of the cubed root of x.
That's x to the 1.
Sylvia, what is it?
X to the 1.
Cubed root of x is the same as saying x to the 1/3 power. Evel, what would you do from there?
Multiply it, right? To the power rule will be 1/3 times x to the power of -2/3.
1/3 x to the power of -2/3. Could not have done that better myself. Actually, I probably could have. And then even better, you could say, well, x to the -2/3 means send it to the denominator as x to the 2/3. X to the 2/3 means take the cubed root of x squared. Love it. All right, let's start the quiz. Yeah, we're listening. Okay, on page 9, there are 3 derivative problems. You have 3 minutes. That seems like plenty of time to me. Page 9. You'll find out. Roll with it, Chris. I have a plan for all the things. I even have a plan to get the insurance company to give me the money that they owe me.
You tell them.
Oh, trust me, I will. Scared the heck out of Kaylin this weekend. She got to hear me in insurance mode, and she was like, Daddy, I had no idea you could talk that way. I was like, yes, I can. I wasn't vulgar. If you're vulgar, they can hang up the phone, but if I'm just strong and educated and powerful, oh, they can't do anything other than cry. All right, page 9, 3 minutes. Those 3 questions, get all of them right, you earn your first sticker.
Yay.
Get any part of anyone wrong, no sticker. Oh, let me erase these.
Are you gonna send it from the start?
I already did.
Oh. The timer's not on.
Make sure you read the question carefully. Jackie, focus. Remember? You sit over there, you're more focused now. I was told. Surrounded by all those big, strong men.
Where? Where?
Okay, Jackie, probably. You do not have to simplify your final answer if you don't want to. One minute left. Time's up. If you could please grab a marker out of the supply kit. You have to get all three right in order to earn my sticker. All right, number one, walking around the room, lots of good stuff happening here. F prime is 12x squared minus 5. Derivative of the square root of 7?
No.
Wait, no? Like you refuse to find the derivative of the square root of 7?
You don't have to.
You don't have to. Oh my goodness, there's a rebellion going on here. Square root of 7, what do we know? It's a constant, and the derivative of a constant is? 0. 0. Not no, not don't have to. The derivative of a constant is 0. F double prime of x is equal to 24x. How many of you guys get that one right? Good. Good luck in the next one. Okay. G of x is x squared times ax to the 4th plus b. We don't have any derivative rules for multiplication yet. Friday we talked about getting to what we call power rule ready form. You have to have it just powers of x with no multiplication or division. So to do that, you have to distribute the x squared through. A lot of folks said derivative of x squared is 2x. True. Derivative of x to the 4th plus b is 4ax cubed. True. But you're multiplying and multiplication does not work nicely. You have to distribute. Now g prime is 6ax to the 5th plus 2bx. G double prime is 30ax to the 4th plus 2b. How many guys get that one right? Liars. For real?
Yeah.
Oh, you guys are smarter than you look. Okay. Number 3, h of x to the e minus 1 over x plus square root of e plus e to the e. I would clean this up first. I would get it in power rule ready form first, meaning maybe I would rewrite this as x to the e minus x to the negative 1 plus x to the half plus e to the e. That's not calculus, that's rewriting. That's getting to power rule ready form. Now I would take a derivative. Power rule says derivative of x to the e, what's that going to be? E times x to the e minus 1. Love. minus the derivative of x to the negative 1 means plus x to the negative 2 plus the derivative of x to the half, 1/2 x to the negative a half plus derivative of e to the e.
No.
No, Henry, stop saying no. E is a constant, e to the e is a constant, and so the derivative of e to the e is 0. That's the final answer. If you want to show off, e times x to the e minus 1 plus 1 over x squared plus 1 over 2 square roots of x is the best final answer. How many guys got all 3 of these right? Okay. All of you that just got all 3 right, go on back to my desk, please. You're going to get a sticker. Okay? I've got the fancy schmancy star stickers. And you get to put a sticker in this first column that says basic derivative rules. You should go and do that right now. For those of you that didn't get the sticker, well, that means you're already failing this unit. No, you're not failing yet.
Okay.
Yeah, it could happen. It's not happening yet. We're going to continue doing the sticker challenge on a daily basis. You'll have opportunities to earn stickers that you didn't earn. Everyone is going to earn all of their stickers. Well, most people will earn all their stickers. Adrian's going to get his stickers too. All right, we've got 35 minutes, and I am so excited. I have 2, count them, 2 derivative rules to introduce you guys to today that are going to, just like me, make your life better. That's what's going to happen. Not easier, but better. We're going to open our eyes to a whole new world of derivative rules. Okay. First one, product rule. Product rule, that you guys know that in math the word product means multiplication. When you see multiplication of functions, you're going to use the product rule. So for example, you have f of x times g of x. If y equals f of x times g of x, you have functions being multiplied together. Here's the product rule. The derivative is f prime of x times g of x plus f of x times g prime of x. F prime times g plus f times g prime. The way that I want you to remember this, the product rule says we take the derivative of the first, like the first function, times the second one. Not the derivative. We leave the second one alone. Plus the first one times the derivative of the second. Okay? So one more time. The product rule says we take the derivative of the first times the second plus the first times the derivative of the second. All right, say it with me on the count of 3. 1, 2, 3. The product rule says we take the derivative of the first times the second plus the first times the derivative of the second. Okay, faster. 1, 2, 3. The product rule says we take the derivative of the first times the second plus the first times the derivative of the second. Okay, just the men. The product rule says derivative of the first times the second plus the first times the derivative of the second. Now just the women. It's going to sound like angels singing on the count of 3. 1, 2, 3. The product rule says the derivative of the first times the second plus the first times the derivative of the second. Rebecca didn't say anything whatsoever. I'm having all manner of questions going on. All right, so let's look at an easy example. This is easy. Find the derivative of this function. I'm going to rewrite it so everybody can see, especially those kids in Ohio. 2x squared minus 3x times x squared plus 1. Is everybody okay that this is a product rule question? Yes. This has to be a product rule question because I have multiplication happening here. Even if I don't write the dot, we see multiplication. Okay. What does that product rule say? Derivative of the first times the second. So find the derivative of the first. What's that going to be? 4x minus 3 times that second. Leave the second one alone. Leave the second one alone. Plus, now we leave the first one alone, times the derivative of the second. That's the product rule. And here's the good news. Here's the good news. If it's the free response part of the test, you don't have to simplify. Yeah. Yay! However, I will put this on the multiple choice part of the test, and you will not see that. Take 30 seconds, show me what you can do.
Oh no.
I'm hiding it from you on the multiple choice. That's how I grow my peoples. This is the perfect answer, Chris, for the free response. You get all the points if it's free response. But on multiple choice, I'm not going to list that as an answer. What am I going to do on the multiple choice to hide it? Diego, what might I do to hide this? Simplify, what do you mean? I can multiply everything out, I can combine like terms, so there's a whole lot of algebra happening there right now. And I'm going to do it up here real quick. 4x times both of these is 4x cubed plus 4x, negative 3x squared, negative 3. 2x squared minus 3x times that is 4x cubed minus 6x squared. 4x cubed, yeah, most of you guys probably did the box here. Negative 3x squared, negative 6x squared, plus 4x minus 3. There was no calculus done there, that's just algebra. This is a perfect answer for the multiple choice. Perfect. 100% multiple choice answer. How many guys successfully multiply that out and get that? 1, 2, 3, 4, 5. Or we're in process of getting there? Okay. Good. I think we have product rule under control. Now here's the thing. What if I had put this question on the sticker challenge just a little bit ago? Before you knew about the product rule, have a quick conversation with the folks around you. What would you have done before you knew about the product rule? Could you have found this derivative without the product rule? And if so, what would you have done? If you didn't know the product rule, or if tomorrow on the way to school you get hit in the head by a rock and the product rule falls out of your head, what would you do instead to find this derivative? I see one person, two. Jeanette, what could you do?
You could just do each part individually, like use like the old method that we...
Wait, the old bad method where you guys took a derivative here and took a derivative here and multiplied those together? Please don't do that. That is not a derivative rule. Eval, what else could you do?
Can't you multiply them both using the box and then take the derivative?
What I hear Eval saying is multiply these out with the algebra first and then take a derivative? Does that sound okay? All right, let's do that. Okay, I know some of you guys are going to draw the box. I'm going to just multiply these out quickly. 2x squared times x squared, 2x to the 4th. Negative 3x times x squared is negative 3x cubed, plus 2x squared minus 3x. That's just algebra. I multiplied everything out. Diego, I need a derivative. What's that derivative going to be? 8x to the 3rd. Keep coming.
Subtracted by 9x to the 2nd.
Subtracted from 9x squared. Keep going.
4x.
Plus 4x minus the derivative of 3x. 3. Hey, guess what?
It's the same.
Guess what?
Oh,
Whoa!
that's crazy.
It should be the same. It better be the same. Otherwise, I made up the product rule and it doesn't actually work. The product rule works. It works really, really nicely. You know.
What was the point of doing that when it should take longer?
Okay, remember, this is labeled the easy example. I picked this one on purpose. I made this one in love and kindness in the calculus kitchen of my house so that you could see the product rule and another way to do it. I want you to have two options. Everybody okay? All right, here we go. New one coming, called the quotient rule.
Yeah.
You're gonna love the quotient rule.
Yeah.
Any guesses when we would use the quotient
When you're
rule?
dividing.
Quotient rule means divide.
Wow.
Okay, all you people reading ahead. Okay. Reading ahead. All right, quotient rule in mathematics. Quotient means divide. We're looking at a division problem here. So if y equals f of x divided by g of x, here comes the quotient rule. It's g of x times f prime minus f of x times g prime all over g of x squared. This is the quotient rule. The denominator times the derivative of the numerator minus the numerator times the derivative of the denominator over the denominator squared. It just flows. No, this is not a proof, but this is the quotient rule. Okay, anybody need a better way to remember this one? Okay, say it with me. Low D high, minus high D low, all over, low low. No, you are not ghetto enough for that. The quotient rule says low D high, minus high D low, all over, low. Okay. Low D high minus high D low all over low. What does that even mean? Has anybody decoded that yet? Low D high minus high D low all over low.
The top.
Top minus bottom.
Whoa, wait.
Derivative of
Low D high minus high D low all over low. High does not mean derivative. No.
I need numerator.
High is the numerator.
D means derivative.
D means derivative.
Low.
And low is the denominator.
Derivative of the high.
Low
High minus
D high minus high D low all over low.
Hello squared.
Low squared. Everybody good? Yeah. Okay, there once was a time, and the kids in Ohio should cover their ears. I taught this about around Christmas time, and I went with high and ho. Stay with it for a second. And we talked about high and ho, because it says that ho d high minus high d ho ho. Ho d high minus high d ho ho. It works beautifully, especially at Christmas time. 20 people come into the room to observe. I'm in the room with class of 2012. I will remember them forever. And I said, where's the high? And they're like, oh, there's the high. And I said, where's the ho? I don't understand what happened. And they all pointed to the same person. I learned a lot that day. I learned you don't say high and ho, you say high and low. One more time on the count of 3. 1, 2, 3. Low D high minus high D low all over low. All right, so let's do it. Okay, derivative of 1 over x. Derivative 1 over x quotient. We're okay? Jackie, come back to me. I lost you and Gonzalo. Ooh. Okay, derivative 1 over x. Everybody saying quotient rule? Okay, do it. Low D high. Low D high. Derivative of high? Low
-1.
D high.
Negative 1.
Derivative of 1, 0 minus high d low. 1 all over low low. That's going to be negative 1 over x squared. Congratulations, you just successfully used the quotient rule. Low d high minus high d low low low. Anybody see another way to find this derivative? What if you had never seen the quotient rule? Could you find the derivative of 1 over x?
Yes.
How many guys see it? What would you do? I want to get some hands in this. I see 1, I always see him, I see 2. Derivative of 1 over x. What did you just do on the sticker challenge, Paul?
1 over x is x to the negative 1.
1 over x is the same as saying find the derivative of x to the negative 1, right? A little bit of algebra. What's the derivative?
Negative 1x to the power negative 2.
Negative 1 times x to the power of negative 2. And that's great. I love that answer. But I need your exponent rules here to also know that this is the same as negative 1 over x squared. And so my 13-year-old would say, oh, same. Okay, they are identical. They are the same. You have 2 different ways to go about doing it. But this was a carefully selected problem to introduce the quotient rule, to give you an example, and you're like, oh, I could have done it another way. All the friends are okay? All right, what I want you guys to do is get the next 11 minutes. On page 11, yeah, let's see what you can do here with this very first problem. Problems 1 and problem 2. I take that back, I'm going to give you 5 minutes. So problems 1 and problem 2. We can take the cups out. Whoever has the longest hair. Finally. Whoever has the longest hair, you're in control of the cups. Cup is on green, things are good. Yellow, you're a little concerned. Red is crisis mode. 5 minutes, show me what you can do for this. Hi, Diego. Oh, you're trying. No, thanks for asking. You can do this, you're strong.
Alright.
Units determined
You can know it.
So low.
Low.
I won't be here much, but I'll be going to The velocity of a particle along the x-axis measured in meters per second will be modeled by the function v of t equals 0.
This is nothing.
Heck, are we going to find
What would it be?
acceleration?
2x plus 1 times. Why 1?
Acceleration.
But then, so we don't have to find the derivative. Just high and then the derivative of the low.
Friends over here with
So this is the denominator and the derivative of the numerator. Low d high. And then
acceleration.
Acceleration is a derivative.
When do you know when to use it?
There it is. So this one you're given velocity. You want to get to acceleration. Friends over here, we doing okay? You've been given velocity. You need to find the derivative to get to acceleration. Good, 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 good. Hi, Corinna.
so for this one, the derivative would be 2t.
2t. All right, for all the friends working from home, we were given velocity. We want acceleration. We know that acceleration is the derivative of velocity. So acceleration low, d high, minus high, d low, all over low, low. Just a quick show of hands. How many of you guys have this as your derivative? Congratulations, you just picked up the first point. Now I want the acceleration at 4. Right, we're just going to plug in 4. So plug in 4. 4 squared plus 1, 17. Times 1 minus 4 times 8. 4 squared is 16 plus 1 is 17 squared. Love it. Great answer. If it's free response, stop. 17. 4 squared plus 1. If it's multiple choice, you do have to go further. 17 times 1. Yep, 17. 4 times 8. 32. 17 squared. Yeah. Not 149. Oh, okay, I'll tell you, it's 289. Andy, does that match what you have? Oh, good. Yep, negative 15 over 289. If it's the free response section, you are foolish to simplify. Foolish to simplify. But if it's multiple choice, even if you just have to go on the side and go a little old school, no one's going to judge. Just get it right. Okay. Now, negative 15 over 289 is good. However, the problem does say units. Don't guess at the units. Know what the units are.
Meters per second squared.
Velocity is meters per second. Acceleration is a measure of velocity changing over time. So the acceleration has to be meters per second squared. Okay, if you're not feeling good about that, let me know. Otherwise, keep going. Try the next one. Or meters per second per second. That's right, keep What part of this are you comfortable with?
P prime, yes.
Okay, do me a favor. Okay, ready? Oh, I already erased it. Is V prime of t is above
That's
it.
the root.
But when do you get to this
I'm ready.
point? What do you have to
You're
do? You have to plug in 4. So what you'd want to say is not that these are equal. So get rid of that equal sign. This guy here is what you get by doing V prime. I am seeing some good stuff.
Oh,
Plus negative 1.
determine the equation. Oh, okay.
Negative 1.
Yes.
You're supposed to add this to check.
Oh wow. Yeah. Oh wait.
Negative 1. That's what I said.
I did that 14.
Yeah, find the equation.
Doesn't matter which one it is.
This is 3 and then this is 4.
Right, for one
So 12.
No, because then how are we gonna play them more?
What?
No.
Two.
Oh, yeah.
Oh, because my mathematics and
Negative.
All right, friends, let's pull it together. Okay, definitely a push. Definitely going in a new direction here. For the function defined by p of x equals g of x times h of x, determine equation of the tangent line of x equals 4. What I saw in a lot of papers is, okay, I need the equation of a tangent line, I need two things. Hey, BC friends? Okay, equation of a tangent line, I need two things. I need the point, and I need the slope. This needs to be automatic at this point. You need the point, you need the slope. I've given you neither of them. You have to do some work to get this. Usually getting the point is easier than getting the slope. How do we get the point?
4-3.
4-3?
No, never mind. I'm
If I want the equation of the tangent line x equals 4, I know the x value is 4. The y value is p of 4. So p of 4, well, p is defined to be g of x times h of x. So p of 4 is what you get when you multiply g of 4 and h of 4 together. What's g of 4?
14.
Oh my.
What?
G of 4 is 3. That was a really enthusiastic wacko answer. H of 4 is -1, so we get -3. That means that the point is 4, -3. Sylvia, don't worry, redemption is coming. I know where the 14 came from. Where does the slope come from? Gonzalo, where does slope come from?
You use the product rule, which is like g prime of x times
Okay, hold
h of
on.
x.
What I hear you saying is we need to find the derivative.
Yeah.
Right, because derivative means slope of tangent line. You've heard me say it like 112 times. Okay, to find p prime of 4, first I need p prime of x. How do I find the derivative of p? P is g times h. I saw a lot of you guys had this. It was the first thing you did. So product rule, g prime of x times h of x plus g of x times h prime of x, p prime of 4, g prime of 4 times h of 4 plus g of 4 times h prime of 4. 14. And I bet it's going to be 14. G prime of 4 times h is positive 2. G of 4 times h prime is 12.
14.
14! It's like an episode of Sesame Street. 14! We get the point? We get the slope? I need the equation of the tangent line.
L of x.
Jackie, what's the equation of tangent line going to be?
14.
14.
X times x minus 4.
Okay, hold on. You want to write it in point slope form. Y equals m times x minus x1 plus y1.
Yeah.
We worked really hard to get the slope. The slope was the hard part.
Yeah.
The point is 4, -3, so this should be x minus 4 minus 3. That's the equation of the tangent line. How many guys honestly had that? 2 people? 3 people?
Forgot the last.
You had that?
Don't call them out like that. You lied!
Because we're struggling and he had it the whole time.
He had it the whole time. That's how Diego rolls. Alright, now it's time for the push. This is going to be our closing model problem. This is problem number 12. I'm going to give you a minute or two, see what you can do with this. Use the cups. Person with the long hair, you're in control of the cups.
Wait.
Oh, bummer. It was L of x 14 x minus 4 minus 3. I'm just going to keep finding ways to push your thinking.
The same thing we just did, but like harder.
To the right is the graph of the no, you don't need to like
Like, I know, like, I got that.
oh, I know you actually do it.
So we went, first one is G prime. G prime of 4. H of 4, H prime of 4. G prime of 4 is negative 2. H of 4 is negative 2.
It's gonna be
Got it?
I just, because I'm not
Okay.
It's because I didn't use
Well, you multiply, but it's on the interval. Or easy, so
No.
negative 1/2.
It wasn't being filmed.
So 3 equals 1.
All right, really good stuff happening when I walked around. There are some super smarties in the room. All right, everybody hold up. We need 5 minutes to finish this off. Shown to the right is the graph of f. Function g is defined as g of x is the cubed root of x times f of x. Using this information, determine the equation of the tangent line at x equals 1. And I heard most of you guys, you're like, I'm not falling for it this time. You know what to do. We need the point, we need the slope. Okay, good. So we need the point, and we need the slope. And where does that point come from?
The graph.
From the graph?
No.
No. 1 comma.
Right, it's going to be 1 comma something.
Yeah.
The something comes from figuring out what's g of 1. G of 1 is the cubed root of 1 times f of 1. The cubed root of 1, everybody knows. 1. F of 1.
2.
Right, this is the graph of f. I can see that this is the point 1 comma 2. So 1 times 2 is 2. That means the point is 1 comma 2. Great. Love it. Love it. The slope means you've got to find the derivative at 1. And this is where this problem just gets ugly. It gets ugly real fast. I need to find the derivative. I think you guys know exactly what derivative rule we need.
The f.
Uh-oh. Right, we're doing a multiplication problem. Product rule. Now, here's a new idea that I want to share with you. The product rule says take the derivative of the first times the second plus the first times the derivative of the second. Is there any part of that that's going to be tricky?
The f of x.
The derivative on the first part? So here's the thing. I'm going to write it this way. I'm going to take the derivative of the cubed root of x, but I'm not actually doing it right now. What I'm saying is I know I have to go take it, but I'm not trying to do it right now. So I'm just saying it's the derivative of the first, now what?
Times the second.
Times the second. The second, not the derivative, just times the second. Now what?
plus
Plus
the first
the first times the derivative of the second. Anybody know the derivative of the second?
F prime.
That's what f prime means. This already gets you a point, maybe even a second point. What I'm saying over here is I'm not ready to take this yet, but I know I have to. And I saw it, a lot of people, they know exactly what to do to find this derivative. Cubed cube root of x. Clever thing we can do here.
1/3 of x.
X to the 1/3.
I would rewrite this as x to the 1/3 so you can use your power rule. Now, power rule.
Let's see.
1/3 less x to the negative 2/3 times f of x plus the cube root of x times f prime of x. This actually means I have found the derivative. That would get you the second point. We need g prime of 1. G prime of 1 is 1/3 times 1 to the negative 2/3 times f of 1 plus the cube root of 1 times f prime of 1. Everywhere there was an x, I just plugged in 1. And let's see, what do we know? 1 to the negative 2/3?
1.
1 to any power?
1.
1/3 times 1 is, oh god, a third. F of 1, you guys told me is 2. Cube root of 1? 1. F prime of 1.
2.
Oh,
Negative.
No, how dare you?
how we do it?
In the graph.
F prime of 1. Marilyn, what's your advice here?
Look at the graph.
Look at the graph. This is the graph of F. This is the graph of F. I need F prime, which means slope. What's the slope?
1/2.
Right? I'm on a line. I can go down 1 and run 2. Negative a half. Let me clean it up. 2/3 minus a half. That's 4/6. That's going to be a 6th. Equation of the tangent line. L of x is 1/6. X minus 1 plus 2. That's great, but that's not done. G of 0.8 is approximately 1/6 of 0.8 minus 1 plus 2, right? It's just what you get when you plug in. Nice job. I'm available tomorrow during lunch. You won't need it yet.